Okay, today we are talking about function notation and evaluating functions. This lesson might be a little more confusing than some others that we've seen, so just pay attention and hopefully it will make sense at the end. I'm not going to give you a formal definition for function notation, but I'm going to show you some examples of things. So somewhere in your past, you've probably seen an equation that looks something like this. Well, function notation is a way of writing the same equation, but it looks different. So you might see something that looks like this. These two equations, they mean the same thing. So if you just kind of put in your memory box that y and f of x mean the same thing, then that will be really good to know. So f of x is just a fancy way of writing a y, and it's specifically called function notation. Now sometimes you don't see it as f of x, you might see it as something different. So I'm just going to write another equation. Maybe you'll see y equals 3x minus 8. Well, maybe this time you'll see g of x equals 3x minus 8. These two equations, they mean the same thing. And so y and g of x, they mean the same thing. G of x is just a fancy way of writing a y. Now most of the time we are going to see it like this, but you're going to see exceptions. And it doesn't always have to be an x in the middle, it could be other letters as well. Okay, so as far as these first problems go, I need you to know that f of x and y mean the same thing. And this thing in the parentheses is typically an x. It doesn't have to be, but it typically is an x. So when I come look at example A, and I see this 6 in the parentheses, I know by looking up here that the thing in parentheses is usually an x, so that must mean that this 6 that's in the parentheses is the x. Okay, so the thing in parentheses, if it's usually an x, then this 6 that's in the parentheses, it's also an x. You know how when you have ordered pairs, you always have an x coordinate and a y coordinate? So if 6 is the x coordinate, I need to know what's the y coordinate. So that's what I'm trying to figure out right here. So if my x is 6, I need to go onto the graph where the x is a 6. And I go right 6 to get there, and I want to know what's my y at that spot. And my y is a negative 3, because we're down 3 off of the x-axis. And that's the answer to that problem. Let's look at the next one. This time, in parentheses, I see an x just like I do up here. So this time, I don't know what the x is. So this guy is the y. That's what I know. And x is what I'm going to try to figure out. So let's go to where our y coordinate is a 0, which means I'm not up, I'm not down. I just need to figure out where my x is. So I start looking, and here he is. And it's left 1, 2, 3. So my x coordinate is negative 3. So as of right now, you need to know that the thing in the parentheses is the x, and the thing it equals is the y. Now this question should be easy. Is this relation a function? And the answer? Yes. This passes the vertical line test. If I draw a vertical line, I only cross one dot. Only cross one dot, only cross one dot, only cross one dot, only cross one dot, only cross one dot. So I'm going to say it passes the vertical line test. So remember, if a vertical line only crosses the graph once, then it is a function. Okay, part B has a mapping for us to look at. So remember, the thing in the parentheses is the x, and you see that we weren't given a number there. That means we don't know what x is. We're going to try to figure out what x is. So that must mean this 8 right here is the y value. So I need to go to where I have a y value of 8. And I see it right here, and I'm trying to figure out what's the x value. And if I look across, I see it's 4. Okay, the thing in parentheses, remember, that's the x. This time I see a number there, so that means I know the x. I know the x is 3. What I'm looking for is what's the y. So I'm going to go to where my x is a 3, and I'm going to see what my y is. Ah, I notice there's 2 y's. So I'm going to answer 3, and I'm also going to answer 5, because those are your y values when your x coordinate is 3. Then it asks, is this relation a function? And the answer is no. And there's a few ways I know this. I know that each x is only allowed to go to one y, and because this x value goes to more than one y, that's one way of knowing that it's not a function. Another is to think of this as this is the ordered pair 3, 3, and this one's the ordered pair 3, 5. And you can see your x's repeat. So I'm going to say no, it's not a function because the x's repeat. Okay, part C says find the following from the relation. So what is this thing in the parentheses? That's right, it's the x. So I happen to know that the x value is -2. What I'm looking for is what's the y value. So I'm going to go to where I see an x coordinate of -2. And where do we see an x of -2? There he is. And I want to know what's the y. And it is 7. So that's our answer. This next one, I see that it's an x in the parentheses. So that means I don't know x this time. X is what I'm trying to find. So this guy over here, that's the y. That's what I know. So I'm going to go to where my y is a -3, which is right here, and I'm going to see what the x value is, and it is 5. Hi. Thank you so much. That's okay. I appreciate it. And then it asks, is this relation a function? So let's look. Do any of these x's repeat? They sure do. You can see this x coordinate of 5 happens over here too. So this is not a function. And that's because the x's repeat. Okay. Now, we're going to look at evaluating a few functions. So I'm going to actually start with this one over here. Now, if you look at this equation, this time we don't see an x in the parentheses, it's an n. But that's okay because n is the variable that you see on this side too. Now if this would have been an x, this would be an x. If this was an r, this would be an r. So it's just saying that we're using n's this time and not x's. So this right here is saying go to the h function. This right here is the h function. And it's saying instead of using an n, use a 5. That's what this is telling me. Instead of using an n, use a 5. So where I see this n right here, I'm going to plug in this 5. So I would write h of 5 equals, and I'm going to put 5 right there in that n, so -2 times 5, and I'm going to recopy plus 4. Now this is just a label, so I don't do anything with this. I just work this side out. So -2 times 5 is -10. Bring down the plus 4. And -10 plus 4 is -6. You subtract, take the sign of the larger, and that equals h of 5. And now I have my answer. So this 5 isn't the x, but it is the n. So it's just telling you, go to your h function and use a 5 instead of using an n. So I'm just going to add a problem onto this. If I said find h of 3, this would be telling me go to the h function, which is this guy right here, but instead of using an n, use a 3. So this time I would plug a 3 into that n. So it would be -2 times 3 plus 4. And then I would work that out. -2 times 3 is -6. Bring down the plus 4. and negative 6 plus 4 is negative 2, and that would be the answer to h of 3. So the 3 and the 5, that's simply what you put in place of the n. Okay, now let's go back to this first one. This one's different. This time, they didn't tell me what to put into the n. So that means I'm not going to put anything into the n. But they did tell me that h of n is negative 2. So I know that h of n, that's this right here, has a value of negative 2. So if this has a value of negative 2, instead of writing h of n, I'm going to write negative 2 equals. And then I just recopy this part of the equation, negative 2n plus 4. So this is telling me that h of n has a value of negative 2. So right here, I know h of n has a value of negative 2, so I just put negative 2 in its place, and I just recopy. Okay, now I want to solve this equation for n. So I'm going to circle everything smushed with my variable. I look on the side of the equals where the circle is. Whatever is outside the circle, I add or subtract. So I'm going to subtract 4 from both sides. The negative 2n comes down. I add and I get a negative 6. And then I'm going to divide both sides by negative 2. And that makes an answer of n equals 3, which is what they were looking for right there. Okay, part E. This asks me to do several things. This right here is telling me go to the f function, which is this one right here, and use a 2. So I look to see what's in the parentheses. Okay, instead of using an x, I'm going to use a 2. So I'm going to put a 2 right there in that x. So let me write down f of 2 equals, so I'm going to put a 2 in this x, so it's going to be 3 times 2 minus 1. 3 times 2 is 6. Recopy. 6 minus 1 is 5. And that is how much f of 2 equals. Well, now I need to figure out what is g of negative 1. So this says go to your g function, which is this one right here, but I'm going to use a negative 1 instead of an x. So everywhere you see an x, we're going to put a negative 1. So I'm going to put a negative 1 right there in that x. So let me write g of negative 1 equals, I recopy the 5 minus, as soon as I see that x, I slap down parentheses, and what are we plugging into the x? That's right, negative 1. The minus the negative makes a big plus, and 5 plus 1 is 6. So that's what g of negative 1 is. Now, what was the problem saying to do? It said take your f of 2 answer, which was 5, add to it your g of negative 1 answer, which was 6, and what do you get if you add 5 plus 6? 11. So that's our answer. That's what goes right there. All right, looking at the bottom. You can't see the grid very well, so this is going to be a little bit harder to eyeball, but I think we'll be just fine. Remember, most of the time, it's the x that's in the parentheses. Okay, most of the time. But we saw before, sometimes it's different letters. So that means this negative 1 that's in the parentheses, that's the x. What I'm looking for is the y. So I'm going to go to where x is negative 1. How do I get to where x is negative 1? That's right, I go left 1. If I want to know the y, I need to know where do I go up or down. So I go down, 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 till I hit my graph. And it looks like about right there. And I'm thinking maybe this is a tad off. It looks like right there. And I don't believe I meant for it to be right there. But it looks like about negative 5. It's not quite at negative 5, but I'm going to say negative 5. I think something happened with my graph when it got copied. Okay, once again I see something in parentheses, so that must be the x. So I'm looking for the y. So I'm going to go to where my x value is 7. So I go right to where my x is 7. And if I want to know the y, I need to know how I go up or down until I hit the graph. So I'm going to go up, 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 up. And it looks like the y value is negative 3. Okay, this time our x is 4, and I'm looking for the y. So I'm going to go right to where my x is 4, and what do I have to go up or down until I hit the graph? Well, I'm right there. So what's our y value right here? That's right, it's 0. Okay, now notice these next three, they're different. I don't know what the x is. X is what I'm trying to figure out. So these guys are my y's. So I'm going to go to where my y is 0. So that's where I don't go up or down. If I want to know what the x is, I need to know how I need to move left or right until I'm on the graph. So if I go right 4, there I am. And that's my x value. So x is 4. Okay, this time I'm going to try to figure out what x is if my y is negative 4. So I go down to where my y is a negative 4, and I need to know what my x is. What do I have to go right or left to hop on the graph? Well, I'm right here on the graph. What's your x value there? Your x value is 0. Okay, and this time I don't know what x is, but I know y is negative 1. So I go down to where y is negative 1, and if I want to know what my x is, I need to either go left or right until I hop on the graph. So if I go to the right, I can land on my graph right there. What is our x value right there? That's right, the x value is 3. Now, one thing I wanted to go back and talk about just real quick before we finish. When you see this, the negative 1 is the x coordinate, the negative 5 is the y coordinate. Let's just see if that really was this ordered pair. Negative 1, negative 5. Not exactly, but it's supposed to be really close to that. This is the ordered pair, 7, negative 3. And let's see if that was on our graph. Let's go right 7, and let's go down 3. No, that's a positive. That's a positive 3. We have a mistake here. When you go right to where your x is 7, your y coordinate is at a positive 3. So I'm sorry, this right here should be a positive 3. Did anybody catch that? Oops. On this one, the x coordinate is 4, and the y coordinate is 0. Let's see if 4, 0 was on the graph. So if I go right 4 and stay put, sure enough. This one I know that x is a 4, and the y is a 0, which we just saw. That's the ordered pair there. This one, the x coordinate 0, the y coordinate's negative 4. And is that one of the ordered pairs on the graph? Sure enough. And then this one, the x value is 3, and the y coordinate's negative 1. Let's see if that's on the graph. Right 3, down 1. Yep, there it is. So, oops, sorry about this one. Hope that didn't mess you up too much. When the x coordinate's 7, what's your y? Your y is a positive 3. So sorry about that. All right, everybody. I hope you kind of understand. We'll make sure that we practice this in class. Thank you.